This opening image is deliberately provocative. It asks what a buried architectural core might look like if selected clues were drawn together into one model. But the first rule is the one printed across the slide. This is a conceptual model, not an excavated structure. No stepped stone pyramid, paired square chambers, painted outer skin, or continuous protective shell of black clay has been demonstrated at Monks Mound. The latest record does establish something rarer and remarkable. In 1998, a horizontal drain drill on the west side passed through about 32 feet of imported stone deep inside the monument. The stone was never seen directly. Its height, width, courses, facing, and shape remain unknown. Follow-up magnetometry reported two possible anomalies, but those also remain unresolved. So the stone mass is documented. The pyramid form is not. The side chambers are more speculative still, and the symmetrical east and west arrangement shown here is not supported by the field record. The burned clay fragments documented in borings occur within separate basket loads. They are not a continuous surface coating. And the black clay bed is a depositional and failure horizon, not a proven sealing layer. The value of this slide is therefore not that it reveals a hidden answer. Its value is that it separates a visual hypothesis from the evidence needed to test it. A measured drilled log, new non-invasive survey, and precise elevation control could refine the stone mass. Until then, the picture must remain a question, clearly labeled, and never substituted for the mound itself. Now step back from the hypothesis and begin with what the record firmly establishes. Monks Mound is the largest earthwork at Cahokia and the central vertical feature of the site. It measures roughly 320 meters north to south, about 300 meters east to west, rises more than 30 meters, and contains more than 720,000 cubic meters of material. Those numbers communicate scale. They do not, by themselves, communicate archaeological sensitivity. The mound is not one uniform deposit. Its interior contains basket load laminations, broadcast fills, clay-rich faces, coarser lenses, sod blocks, buried turf, stable surfaces, faulted contacts, slump scars, and repair episodes. Each boundary records a decision or an event. Builders selected soil, moved it, placed it, paused, renewed surfaces, and sometimes responded to instability. Later failures displaced those earlier relationships. This is why a cut that removes only a small percentage of the total mound can still cross unique evidence. A narrow bench may intersect one prepared surface, one feature, or one construction interface that exists nowhere else in the exposure. The slide's main synthesis is therefore straightforward. Monument form and internal stratigraphy are inseparable. The exterior tells us that a monumental platform was created. The interior tells us how it was created, altered, maintained, and repaired. Broader earthworks such as Great Serpent Mound and the Newark geometric complexes help place mound building within a continental tradition. But they are background comparisons. The strongest direct case on this slide is Monks Mound itself, a terraced monument whose layered fabric is architecture, not interchangeable dirt. This slide turns from form to process. The builders of Monks Mound did not simply heap soil upward. The profiles show staged construction using different techniques and different source materials. Some deposits were carried in baskets and remain visible as thin, repeated loads. Other fills were broadcast more broadly. Sod blocks were cut and placed as units. Prepared surfaces divided episodes. Selected wetland-derived soils were brought from lowland settings, while other loads carried occupation debris, plant remains, charcoal, pottery, or burned clay. In parts of the profile, roughly 16 to 20 basket loads occur in a single vertical meter. Multiply that density across the monument and the scale of coordinated labor becomes difficult to overstate. The radiocarbon synthesis places the main construction sequence broadly around AD 1050 to 1150, with capping and later work extending toward AD 1200. That chronology supports rapid monumental growth, followed by continued alteration rather than one single event. Maintenance also belongs in the story. Slumps, faults, repaired faces, and renewed fills show that stability was an ongoing concern. Construction and repair may not have been separate categories to the people doing the work. They may have been parts of the same continuing obligation to sustain the monument. What can we infer from this? Large-scale scheduling, technical knowledge, soil selection, and organized labor are strongly supported. What we cannot fix from these profiles alone is the exact governing institution. The evidence does not identify a single office, title, or political mechanism commanding thousands of workers. The strongest claim is more careful. Monks Mound was a long-duration public work requiring durable coordination, specialized knowledge, and repeated renewal across generations. The fourth slide is organized into 3 evidence zones, and they must not be collapsed into one. On the left are direct finds from the 2007 stabilization contexts. These include cord-mark pottery, a catfish spine and other fish remains, bone, microdebitage, maize, hickory nutshell, wild grape, and seeds associated with the Eastern Agricultural Complex. These materials matter because they were recovered from features, construction deposits, and samples within the mound. They demonstrate cultural content and environmental information. By themselves, they do not prove elite craft production or long-distance exchange. The center panel presents the broader Cahokia context, shell beads, copper, mica, gamestones, projectile points, and other materials known from the regional archaeological record. These show that Cahokia participated in wide networks of production and movement. But the stabilization cut is not the provenience for every item pictured in that broader group. The right panel moves forward in time to the River Lobby mission assemblage on the first terrace. Glass beads, catalanite pendants, marine shell, fence, bottle glass, knives, gunflints, bells, crosses, and brooches document 18th century French and indigenous interaction. That is a secure post-contact case. It should not be used as a direct proxy for pre-contact exchange or assumed to overlap the 2007 cuts. The governing principle is provenience. An artifact is most informative when its exact layer, feature, depth, and associations are preserved. The slide therefore does not tell one simple trade story. It shows 3 different scales of evidence: direct stabilization finds, regional Cahokia comparators, and a later historic interaction assemblage. Keeping those scales separate makes the interpretation stronger, not weaker. This aerial reconstruction places Monks Mound within the larger Cahokia landscape. The monument stands at the core of a planned setting that included the Grand Plaza, mound clusters, domestic zones, palisade and boundary features, wood hinge, and specialized compounds. Beyond the central precinct were satellite communities such as Mitchell, Remy, Cahokia, Prairie du Pont, Mill Creek, and Depot. The pattern is not a solitary mound surrounded by empty country. It is a regional settlement system with a monumental center and connected communities. Monks Mound's scale and position support the interpretation of the coordinated ceremonial and political core. Public space, elevated architecture, domestic occupation, and controlled boundaries were brought into one designed landscape. Nearby mortuary evidence, especially Mound 72, demonstrates an equal treatment and elaborate display within the region. But the distinction printed on the slide matters. Mound 72 is regional context. It is not evidence recovered from Monks Mound itself. The same caution applies to political labels. Monumental construction and differential mortuary treatment support social complexity, hierarchy, and coordinated authority. They do not require us to impose one uniform model, one title system, or one permanent bureaucratic structure on every period of Cahokia's history. Settlements change. Alliances change. Leadership and ritual authority may be distributed differently across time. The strongest conclusion is therefore both substantial and restrained. Cahokia combined monumental, ceremonial, domestic, and bounded spaces within a regional hierarchy. Monks Mound was its dominant architectural focus. The landscape supports social differentiation and large-scale coordination, while the exact offices and political mechanisms remain interpretive questions. The sixth slide follows the materials from field and wetland into foodways and construction. Maize is present as kernels, possible kernels, cupules, and a glume. Hickory nutshell, wild grape, annual weeds, wetland plants, and eastern agricultural complex seeds broaden the assemblage. Fish and other fauna add another dimension. The combined record includes fish remains and, in the river Labi material, deer, raccoon, duck, gar, terapan, turtle, mussel, and black bear. These are not just menu items. They show how people moved across fields, forests, river margins, wetlands, and backwater habitats. The central image connects subsistence to mound construction. Quillwort, spike rush, and other wetland indicators point toward moist lowland soil sources such as meander scars and borrow pits. The same landscapes that supplied food and weathered resources also supplied enormous quantities of earth. Plant remains were incorporated into fill, sometimes rapidly sealed under low oxygen conditions. That sealing preserved delicate and carbonized seeds that would normally decay. The result is a record of both land use and construction practice. The assemblage supports farming, foraging, fishing, hunting, and wetland resource use. It also supports deliberate selection of soils from different environments. What it does not demonstrate is an administratively managed surplus economy. The files do not establish centralized granaries, fixed redistribution offices, or a precise measure of dependence on maize. Those possibilities belong to broader research, not to this corpus alone. The most defensible synthesis is that construction landscapes and subsistence landscapes were closely linked. Building Monks Mound required intimate knowledge of the same riverine environment that sustained Cahokia's population. This is the methodological center of the presentation. On the left, the slide shows the work archaeology can recover when a deposit is recorded in place: monitoring, mapping, photography, flotation, selective sampling, and three-dimensional provenience. On the right, it shows what happens after stratified soil becomes mixed spoil. Objects may still be visible, but their original relationships are gone. A sherd separated from its surface, a seed separated from its feature, or a bone fragment separated from its depth can no longer answer the same questions. The best current volume model places the 2007 removal between roughly 2,000 and 2,700 cubic meters, with the best single estimate near 2,400. The exact share of original mound fabric remains unresolved because much of the east cut passed through modern repair loss, while parts of the excavation reached intact construction deposits. Systematic screening of the entire removed volume was not a promised task that simply failed. It was absent from the approved archaeological design. The planned method was monitoring, mapping, photography, and selective recovery, and substantial work of that kind was performed. The preservation problem is that the cut became larger than the shallow bench concept, so a greater volume passed through a selective rather than comprehensive recovery system. The record therefore contains two truths at once. The project produced the most extensive interior profiles yet documented at Monks Mound and generated major scientific information. It also created irreversible context loss, especially once soils entered mixed spoil. The broader administrative finding is incomplete documentary conformity. A real engineering threat, real review, and real archaeology are documented. The complete plan set, field change gear, authenticated as built package, and long-term monitoring chain are not. Future work must preserve the three-dimensional relationships, not merely collect what remains visible after removal. The eighth slide is a 1964 topographic survey. It is quieter than the illustrated plates, but it supplies essential control. Contour lines translate the mound's visible form into measured elevation. They define terraces, steep scarps, broad platforms, irregular slopes, access routes, borrow pits, reference points, and drainage features. The 2-foot contour interval allows changes in gradient to be followed across the entire monument. This map is a baseline, not an interior blueprint. It cannot show buried surfaces, stone features, or the depth of a failure plane. It can show where later observations belong on the exterior form and how repair areas relate to terraces and slopes. Historical surveys are especially valuable because the mound has changed through erosion, slumping, excavation, backfill, drainage work, and surface restoration. A modern contour surface may record those later interventions. An earlier survey preserves part of the pre-repair geometry. Used together with the 1984 mapping, the 2005 survey, boring locations, and as-built records, it can support repeatable comparison through time. The lesson is that location control is not a technical afterthought. Every core, feature, photograph, and excavation phase becomes more informative when tied to common horizontal and vertical data. Without that control, separate observations remain difficult to connect. With it, changes in the mound can be measured rather than merely described. This slide brings 4 deep cores onto one elevation frame. MMD 1, 2, and 3 cross the west flank. MMD 4 is the critical east face core taken near the area later excavated in 2007. The logs record texture, color, soil horizons, inclusions, shear planes, and intervals of no recovery. Their first major lesson is structural. Slick end sides and shear zones recur within or near dark, clay-rich beds. Those horizons retained water and became failure surfaces. The 2007 repair was designed to reach and remove unstable material associated with that system. Their second lesson is archaeological. Cultural material occurs in every core. The logs include pottery, daub, charcoal, bone, lithic material, limestone, shell, and a bake or exposure surface. MMD4 contains limestone fragments near the top, a snail shell, charcoal, a lithic, a possible vertical feature boundary, a pottery sherd, and several shear planes. The cores therefore do not support treating the mound interior as uniformly sterile. One correction is important. The inclusion marked in MMD1 is vivianite, not volcanic material. Vivianite is a hydrated iron phosphate that can form where iron, phosphate, water, and low oxygen conditions coincide. In this core, it occurs within black clay at depth. That is consistent with a reducing, phosphate-enriched environment. It is not, by itself, evidence of intentional blue pigment or burial. Blue is a clue, not a conclusion. Burned clay must also be kept separate from the black clay bed. Burned clay occurs as fired fragments within certain cascade loads. The black clay is a stratum and a failure horizon. The core record matters because it connects engineering behavior, construction history, and archaeological content in the same vertical sequence. The final slide maps active and relic mass movement features on the west side of Monks Mound. Red lines trace active scarps. Blue lines mark older or relic scarps. The 3 west side borings and monitor wells are placed against the contour surface so that subsurface observations can be read within the geometry of movement. The map makes one fact unavoidable. Instability is not a single modern accident. The mound has a long history of slumping, reactivation, repair, and renewed movement. That history creates the central preservation dilemma. Doing nothing can allow erosion and slope failure to destroy the monument. Intervention can also destroy the relationships that make the mound an archaeological record. The answer is not a slogan for or against excavation. It is a method. Define the area of potential effects in 3 dimensions. Authenticate the exact plan version. State the recovery standard before work begins. Record every field change and every stop and restart decision in real time. Tie cores, faces, samples, and features to shared survey control. Maintain performance monitoring after construction. And involve descendant native communities in decisions concerning a monument whose meaning is not limited to engineering or academic research. The 10 slides together move from a conjectural image to measured evidence. They show scale, construction, labor, materials, settlement, foodways, disturbance, topography, stratigraphy, and active geomorphology. Their strongest shared conclusion is simple. Monks Mound is at once architecture, landscape, archive, and living preservation responsibility. Every intervention must protect not only the mound's shape, but the relationships held within it.